Hi guys, welcome back to Enginerds YouTube channel. My name is Patricia Bermudez and I will be your host for today's video. And for today's video, we will be discussing a equation that is used for systems that have two phases that are in equilibrium. They have either solid or liquid that is in equilibrium or liquid and vapor that is in equilibrium. So the Clausius-Clapeyron equation is given by this formula. We know that ln P2 over P1 is equivalent to the negative enthalpy, change in enthalpy over R, which is the universal gas constant, and then 1 over T2 and minus 1 over T1. And dapat itong T2 na to naka-correspond siya dito sa pressure here, and yung T1 here naka-correspond din sa P1 in this logarithmic function. So here we are given two sets of values, okay? So we have this one and this one. So let's list them down. So we know that the temperature T1, let's say this one is T1, is equals to 90 degrees Celsius. And then we have P1 that is equivalent to 293 millimeter mercury. And then we have another set of value, and we have 100 degrees naman. So let's say it's T2. T2 is equals to 100 degrees Celsius. And then we have P2 that is 417 millimeter mercury. So ngayon, in this equation, meron tayong dalawang sets of values. Okay? And the question is asking for, so these are the given. What is required? Ang required in the problem is yung normal boiling point. Normal boiling point of acetic acid given these two sets of parameters. And when we say normal boiling point, it is actually the boiling point at sea level. And what is our pressure at sea level? We know that the pressure at sea level is equals to 1 atmosphere. But since all of this pressure values here is in millimeter mercury, we have to convert 1 atmosphere to millimeter mercury as well. So we know that 1 atm is equivalent to 760 millimeter mercury. So the question is asking, what is T if P is equals to 760 millimeter mercury? What is T? So that is what the question is asking for. So here, since we're given these two sets of values, and if we substitute these values into the equation, ang makukuha natin is our change in enthalpy, or the enthalpy of vaporization. So that is our first step in this problem. We have to find the enthalpy of vaporization. Okay? So we know that Ln, ang P2 natin here is 417 millimeter mercury over our P1, which is 293 millimeter mercury. And all that is equals to the negative change in enthalpy of vaporization over R. And here, we can just use 8.314 para yung delta H VAP natin ay naka-joules per mole also. Okay? So, 8.314. And ang unit niyan is joules per mole Kelvin. And then our T2 here is 100. But since this value or this temperature ay naka-fraction, we have to convert this into Kelvin. Kahit change siya kasi inverse ng temperature na yon. And when you're taking the inverse of a temperature, it has to be in absolute temperature, either in Celsius, either in Kelvin or in Rankine. Kasi Celsius and Fahrenheit are not absolute temperatures. You cannot use it in fractions or in ratios, okay? So you have to convert this into Kelvin, okay? So, ayan. And how do we convert into Kelvin? We just add 273.15. So, ang T2 natin here would be 100, right? So, it'll be 100 plus 273.15, and that is 373.15. And our T1 would be 90, right? So, ito minus 10, it would be 363.15. And this one is in Kelvin, and this one is in Kelvin as well. So, if we're gonna do unit cancellations, makikita natin na dapat yung nasa loob ng ln makancel. Kasi dapat ito ay unitless. Okay? So, mmHg, makacancel. And then, itong Kelvin. Ito, it's technically 1 over k. And ito ay 1 over k na nasa denominator. So, ito makacancel din here. Ito kasi technically, nasa numerator siya. Dito siya nakamultiply. Pero ito, nasa denominator. At itong k ay nasa denominator ng denominator. So, ito, makacancel siya. Okay? Parang ganito lang siya. We have 1 over k. Tapos, itong unit na to, joules per mole Kelvin. So, makacancel yan. Kasi parehong nasa denominator. Okay? So, matitirang unit for delta H is joules per mole. Why? Kasi itong one side of the equation is unitless. So itong side of the equation has to be unitless as well. And how do we make it unitless if delta H vap is in joules per mole as well? Kasi makakancel yun. Okay? So now let's calculate for delta H. So kung i-isolate natin yung delta H vap, it will be negative delta H vap is equals to this ratio here. It will be ln 417 over 293. Tapos, itong nasa denominator, mapupunta sa numerator on the other side of the equation. So, magiging multiplied by 8.314 joules per mole. And then in this one, so yan, magiging divide na kasi nakamultiply siya here. So, if you're gonna transpose it to the other side, it will be divide. So, it'll be divided by 1 over 373.15 minus na-cancel na yung Kelvin, so hindi natin isusulat yan. 1 over 363.15. So, calculating, we have ln 417 over 293 times 8.314 and divided by 1 over 373.15 minus 1 over 363.15. And our delta H vap is negative 39,760.14185 joules per mole. And dahil naka-negative both sides, pwede natin cancel yan. So delta H vap is actually equivalent to 39,760.14185 joules per mole. Ngayon, hahanapin na lang natin here is this, the temperature if the pressure is 760. So we can choose either, kahit saan dito. Ito, pwede natin gawing P2. Ito, pwede natin gawing T2. So ang gagamitin nating value here is this one. Or you can also use this. It's up to you. And even if you use this as the one you chose, yun din naman lang sagot na lalabas for T2 here. Okay? So, therefore, ang ating RT would become ln or so ito yung magiging P2 natin, 760. Okay, 760 mm Hg over yung P1 natin here, which is 293. Is equivalent to negative delta H, which is this one, negative 39,760.14185 joules per mole over R, which is 8.314 joules per mole Kelvin. And then yung T2 natin here is unknown. So ito yung hahanapin natin minus yung T1, which is 363.15 Kelvin. Okay. So we can see ang makakancel dito is mmHg again, then joules, and then per mole, and then Kelvin here. Therefore, yung T2 natin would also be in Kelvin. Okay? So, if you want to isolate T2, ang mangyayari dito is ln 760 over 293 multiplied by 8.314 over negative 39, 760.14185. Okay? And then, ipa-plus natin. Kasi ito, tinranspose natin here. If you're gonna transpose this, itatranspose mo yung reciprocal. Okay? So, ngayon, nagawa na natin yan. Ito, ang itatranspose lang natin, itong negative 1 over 363. So, yung negative magiging plus 1 over 363.15. And that would be equal sa 1 over T2. So, paano makukuha yung T2? Eh, kung nasa, ano siya, denominator siya, if you take the reciprocal of both sides of the equation. Okay? Negative 1. And ito, negative 1. So, ang makukuha mong value here na naka-reciprocal is equal to T2. Okay? So, therefore, T2 would be equal to 391.485 Kelvin. Okay? And that is our solution for the problem. That is the normal boiling point of acetic acid. Okay? So, I hope you guys learned a lot from today's video. Thank you for listening and stay tuned for the next one. Bye-bye.